Day 132, Honors Physics, Electrostatics, Electric Fields, problem number 25. So I have them outlined here. Part A I have over here on the left in this region. So here's the scenario. We have 3-point charges at the corners of an equilateral triangle with sides of 60 centimeters. All right, and we're looking at the point dead center, which I haven't geometrically figured out the distance yet, but it's less than 60 centimeters to each corner. But I don't need to figure out the distance because you can make a quick argument that these three vectors will cancel out to 0. First of all, there's going to be three fields here. So E sub 1, E sub 2, E sub 3. So here's E sub 1 due to this charge right here towards that negative charge. So this vector goes with the field at this spot due to this charge right here. And you could use the equation E equals KQQ over, or E equals KQ over the distance squared, because you could figure out this distance, and you would get E sub 1. But it's the same distance and same charge here, same distance, same charge here, so all three of these vectors are the same. You can look at this for a few seconds and tell it's going to be a net force when you add these three vectors up to 0, because, first of all, if you look in the left and right direction, these two vectors are equal in size and angling down at the same angle, basically 30 degrees with the horizontal if you do the math here. So they have the same components left and right that'll cancel. Or if you just take either one of these vectors, like E sub 2, and you can do the same thing with E sub 3, which is kind of down and to the right. But E sub 2 is like this. It has an x component in this direction, which would be canceled out by the x component of E sub 3. So there would be no left and right net field. And downward, if you remember your rules for 30, 60, 90 triangles, of which this is a third, this is 30 here, 60 here, 90 here. This short leg of a 30, 60, 90 is 1/2 of the hypotenuse. So this would be 1/2 E sub 2. Well, there's two vectors in this problem such that, in other words, if you do E sub 3 also has that vector component. So E sub 3 would have another 1/2 E sub 3, but E sub 2 and E sub 3 are the same, so 1/2 plus 1/2 gives you a total vector down. This plus the other half would be a full vector down, which would cancel out E sub 1. So there's the argument that the net field is 0. In part B, here's the diagram. Same scenario as far as the 3-point charges at the corners of an isosceles triangle with sides of 60 centimeters. So down here at the bottom, here's the midpoint of the bottom, which would be 30 centimeters from either of the bottom vertices. But E sub 1 and E sub 2 would be equal to each other, simply, once again, due to the fact that we have the same distance from this spot to this corner and this spot to this corner, the vectors being pointing at these negative source charges, same size charge, same distance, so E sub 1 and E sub 2 would be the same magnitude, opposite directions. They would cancel. However, E sub 3 would not cancel here. But this becomes an easy vector problem because of the fact that E sub 1 and E sub 2 do cancel. All you need to do is figure out E sub 3. It's one calculation, just plugging into E equals KQ, this being the Q, over this distance squared. I'll let you figure out that distance. It's not too hard to figure out that distance, but it's not 60 centimeters. Use geometry to figure out in an equilateral triangle how long is this altitude. It's less than 60 centimeters. You figure that out. Once you have that, it's an easy, just plug into E equals KQ over that distance squared.